Hey there, welcome back to something that's new, bit of an experiment. I'm trying to do more coding videos. It's kind of winter, I feel like I want to sit inside and write code instead of trying to fix computers in the sun and everything. So, what I'm going to do is continue my Spectrum Next videos learning how to use it. But they're videos that take a while to make, it can take a month to create a video on how to do sprites. Because I've got to actually learn it myself. So I thought every other week what I'd do is produce some sort of coding vlog type thing, which is what this is, where I just go through learning stuff and messing around with it. Today what I'm trying to figure out is how to do fixed point maths and kind of remember how to do sprites and everything, which is quite convenient that I made some videos on it because I'm using them as well. But yeah, if you didn't know, the Spectrum Next, which is this thing, it's got an 8-bit CPU, there's no floating point unit inside it, so all the maths has to be integers. If I try and use floating point maths, it kind of either doesn't work or it grinds to a halt trying to calculate it. So we're doing things the old-fashioned way. That mostly being fixed point maths, which I will do a proper video on, and this is me learning how to do it. I'm not trying to make any specific thing, but I figure if I can get some sprites moving around the screen, I'd quite like to make, I don't know, a sort of little driving sprite that can drive around, and then something that just moves with a bit of inertia. Quite like games where they're not static and then suddenly moving at full speed and it all just feels a bit, too 1980s. Quite like games that feel alive. So I think that's enough waffle, and we'll just get on and do it. Now, to make these videos a bit more interesting to watch, it's not just going to be an hour of me typing code and looking confused and running stuff and muttering to myself. I mean, there'll be some of that, so, if you like that kind of thing, just keep watching. But I've got a different set of views that I can show you. So this is my coding view with the code in it. I'm not going to go through lines of code and try and tell you what it means. I'm just going to write code and explain what I've done. And then I've got another view, which is my next. So you can see me actually using it. And you can kind of get a bit of a sneak peek on something that we're doing. A little sprite that spins around. So that's kind of how we're going to do this. Just me talking and coding and pausing it occasionally and coming back after I've figured stuff out. Right, so if you look on the screen, what we've got is a little dude, and I have my joystick. So what I want to do is move him around the screen using this. So if I can go and he moves, that'll be a nice starting point. So what I need to do, here is the code. These 16s, I believe, are his position. It's been a while since I've done this, I'm trying to remember what I'm doing. So let's budge something in here. So let's set those like this to begin with. Right, so if this works, the sprite should be in a different position on the screen. Have a look. Wait for it to sync. Okay. Yeah, he's moved. He's in a different place. Let's just check that again. So I set him to be at, I don't know, somewhere in the middle, 128, 128. Rerun the make. Resync the machine. Right, I don't know if you can see it, but here's a little ESP board that's using Wi-Fi to connect my Next to the machine I'm doing the development on. And then it runs Next Sync to copy it onto its SD card. Saves farting around with all the different memory cards and memory card readers and stuff. There we go, right, it's in a different place. So we need to make it so I can move this to move him. So it first means working out how to find this joystick. So we need to look in the manual, which is here. So port 31 and port 55 are the two joystick ports. So I need to remember how, using Z88DK, we access those ports. Now, I've done this before in other places. Let's go and have a look. I think he does call IO whatever. Right, let's see if it understands that then. So which ones are we after? IO1F and 37? Don't know, let's try something. Okay, it didn't complain about that. Right, maybe that's how we do that then. So if I've got this thing here that I've called test, I don't know which port is which. I don't know if that's port 1 or that's port 2. So what's the other one? That can be joystick 1. You know, this is fine, but there's no sort of... If right is bit 0, okay, no, that's fine. That means if it's non-zero, it's got something to do. Right, let's just try that really simply then. If joy1 is not equal to 0, or joy2 is not equal to 0, let's just put it in somewhere totally different, like 0. Right, if you move the joystick, it should go to the top corner, otherwise it'll stay in the middle. Let's see if that works. Oh, it doesn't like 37. This is where I find it's actually been done for me. Let's see if there's already an input. I'm not trying to reinvent the wheel the hard way. Surely that should be called. Surely at some point I should define that. Let's see if that... Yeah, surely it's defined in here. Ah, in stick. In stick, Kempston. Okay, returns a 16-bit int. Let's go have a look at you. Okay, it does some magic that we can't see. Maybe that's the thing though. If in doubt, stick it in Google. This is why I make these videos, because I just want to move the guy with a joystick. It's difficult finding out how to do that. There is no documentation. Literally looking through forums trying to find it. So I do the hard work, then I tell you how to do it. Easier. So keep watching. We're going to figure this out. See, I don't know how to use this. I found it. Okay, I've got this in-stick Kempston thing. But I don't know what it just returns an unsigned 16-bit int. And before we get too invested in it, let's even try and run it. See if it even compiles. Right, does this even compile? Appears to. So if this works, I should be able to move the stick and the guy moves. Oh, wrong place. Oop. Okay, that's doing nothing. Perfect. Let's try the other part just in case. Oh. Ah. Okay. So that reads that part, not the other one. Wait, I thought Kempston joystick was 2. It is, because it lists it as 2. Right, if joystick and in stick down. Right, let's do this one step at a time. So what I've got now is if you press down on the stick, you should react. Right, this is good. What we need to do now is just turn this into slightly more sane code that does something useful. Right, so we just need a bit of simple logic here. That doesn't do any of that. Well, that's good. I thought I'd have to write my own joystick routine. So, the stick is down. Let's see if the stick is up. Now we need left and right. Really confused why that's not defined. Surely by including this, it should include it. Surely that's like part of this. Anyway. So, if you're moving down, we just do x pos plus plus. If you're moving up, we go, no, y pos, oops. we do y pause minus minus, because this is not Python, these actually exist. Move it left, we take it off. Okay. See what happens. Can I move him around the screen? Need a way of automating this bit, it's irritating me. Okay, he moves. That's quite good. Diagonals work. Cool. Okay, we have some man action. Look at that. He moves around the screen, which is pretty cool. Right, he needs to move faster. This is very, very slow. What's he do at the edge? Oh, he wraps. Yeah, I thought he would do. That's fine. We'll ignore that for now. Okay. So he moves. We can have a movement speed, I guess. Try moving by 5. Don't know why it syncs the whole thing. It should just sync the file that's changed, but never mind. Cool. We have him moving around. That's nice. Because that's not actually what I wanted to do. I want to make him move with a bit of, you know, interest. He needs some inertia. This feels very 1980s video game. Where your little guy just moves and stops immediately, and there's no inertia or sliding or anything nice. Let's add a bit of that. You see, I was looking on the internet like you do. And you can get very lost looking on the internet. Where is it? Here we go. Right, so I was looking and I found this website, which is Game Mechanic Explorer. And I want to make this kind of thing. You know, good old bit of asteroids, ship movement. And conveniently, underneath, they're giving us some source code we can look at. But the problem with the source code is it's all floating point numbers. Okay, we're dividing by 2, which is not, but you know, this is floating point stuff. It's involving Cosine, Sine and all that stuff, which the next cannot do. It does not have a floating point unit. If I try and write for x equals 1.0, I don't think it even compiles. Oh, it compiles now. It must link in a floating point library. Either way, you don't use floating point numbers on a 8-bit CPU that doesn't have a floating point unit. That's not how things are done. So what we need to do is fixed point numbers, which is the whole thing I'm trying to actually work out. So what I made earlier was a little bunch of hash defines for fixed point conversion. And then there's a lookup table and sine and cosine. So let's see if we can turn this into the little guy sort of moving around the screen. Right, so I'm going to explain fixed point numbers in another video. This is just me trying to work out how to actually practically use it. So I've got this fixed 8 data type I've invented, so we need one of them for the x and y position. So they are no longer, oops, need to include it. So they're no longer integers. I can pretend they're floats, which also means that needs to be as well. Okay. And it's not going to be 5. It's going to be some number. Maybe the compiler will convert this for me so the CPU isn't doing it. I think it will. Because I don't know how fast to make things move. Like 5 pixels each time seemed fine. So let's try that again. In fact, let's try and recreate what we did a minute ago. Just using fixed point maths. So we've got, they're not going to be called xpos and ypos. No, that needs to be a, because that's the screen. Need to not mix these up. There. So down here we can say right, this should do absolutely the same thing as before. Okay. No, let's cut this bit out because I've tabbed this thing on the screen. I'm just checking it's even working. Cut this bit out as well. Right, so this should behave just as it did before. Let's have a go. Oh, come on. Yep, that feels pretty much identical, which is good. It means I've not broken anything by using my fixed point maths, which actually is dead easy. Again, I'll explain this later, but at the moment I'm just multiplying everything by 8, kind of, or whatever it is, and then dividing it again. So It's not doing anything particularly clever. But I should be able to set this to be smaller than 1. So now the little guy should move really slowly across the screen. Yeah, I should be able to do it even slower. Yeah, look, it's like he's moving less than a pixel per frame. He's not really. It's just taking him more than 1 frame to move a single pixel. And it looks a bit juddery because on the next the pixels are quite big. So that's working fine. This is good. So now we can do some actual maths to make him whiz around the screen in quite a fun way. So we need to work out what's going on with this stuff. Just have a bit of space to write some code and find what we're doing. Let's actually mix things up a bit. There's one in here for walking. This is the one with a bit of acceleration to it. Yeah, but it's not that great. Let's try and recreate this. Help if I actually showed you the screen. Edit out the other crap, put this bit in. Right, so what we'll try and do is recreate this, where he moves with a bit of inertia. So he's got maximum speed, he's got an acceleration, he's got a drag. Although none of this does the actual maths, this is less helpful than thought. Let's go to the website everybody visits, because it explains it nicely. Here we go. Got position, velocity. They always put it upside down, but then he kind of puts it correct. See, why would you say your position is your velocity and then work out the velocity from the acceleration? You should do that first. Dumb. Don't understand it. There's people that do that one. Do this one. Right, we don't have a delta time because I don't actually know what that should be. Right, so what do we need? We need a position and a velocity, which means we need vector 2s. Oh look, I've made one. Right, let's include vec2. Because then we can say vec2 position, vec2 velocity. Acceleration. Means we don't need world x and y pos. Position.x. Position.y. What am I doing? Right, we'll keep the screen X and Y position. So we need to do the good old integration, which is velocity dot x is equal to acceleration dot x dot y is equal to acceleration dot y, position dot x, add on there. Set these to be nothing so it doesn't skid around the screen weirdly. Oops. Right, we're not moving the position. We are going to... Where's that website gone? Not you. Right, so if you press the button, you set the acceleration to the number, otherwise you set it to 0. Then we need an acceleration amount. I have no idea. Let's try 0.5. If we're pressing down, acceleration at y is going to be that. Otherwise it's going to be the negative. Otherwise it's going to be 0. That one's a negative. So then his velocity will keep moving. If we want drag, we can deal with that later. Right. Let's see if it works. No, that didn't work, did it? Come on. Yeah, it's working, but he accelerates far too fast. It's like he's... Yeah, that's uncontrollably quick. But it's working, which is cool. So 0.5 is too much. Let's try 0.1. This is why we need floating point numbers, you see. We need to have numbers smaller than 1. this is working, this is nice. Feels a bit wobbly, but I think that's just the resolution of the screen. It's not racing out of control. And it doesn't feel too strange. It's like it's not as smooth as doing it on a PC. But it has the same sort of weird jiggliness that Spectrum games used to have, where you're forcing an integer-based CPU to do floating point maths in a sort of roundabout way. So yeah, no, that's cool. Stop moving. Right. Nice. Right, so something nice that'd be on this is if it had drag, so instead of just continually moving forever, eventually slid to a halt. So we can do that, I think. Let's give it 0.1. I'm going to have to change that, otherwise you'll never set off moving. Let's change that to 0.5. And I guess after we've moved him, what we can try and do is just reduce his velocity by that value. But then cap it at 0. At each time though. Oh, I don't know how to do this bit. Because his x velocity might be positive to make him move the other way. Oh, I need to figure this out with some internet research. And we've done integration, a very useful website. No, not drag and drop. Man, people get way over the top. So drag is resistance to velocity determined by volume of air. This is clearly way down the rabbit hole of randomness. What even are we trying to do? Why are you doing air velocity and stuff and sweeping things? What? Right, well, if drag is opposite velocity, then we just need a vector in the opposite direction. And I guess we actually add it in. Maybe we can cheat this. No, this feels wrong. I may have to go away and think about this. Right, time has passed, and what I've managed to hack in now, it doesn't feel mathematically correct, but it works. So, is there a better way of doing this? What I wanted was the little guy slows down when you stop moving, so he doesn't just keep sliding across the screen forever. So I worked out what I'm calling drag, which I don't know if that's the correct term for it. And I'm doing it the stupid way. if your x velocity is bigger than 0, just set a drag value to some negative number to combat it, and then add it in, and do the same for the other way around. And then limited the velocity so it wasn't going crazy, and would also stop. So if we look at how this works, here's our little man, and now he slows down. Ignore the fact he wraps around the screen. And it all stays nicely controllable. I'm not trying to write a game, I'm just playing around with the maths, trying to make this fixed point stuff work in my head, and create something that I could turn into a game later on. That's the whole point of this. We're just having fun, trying to work out how this works. So, the next thing to do is to maybe do some other kind of motion. This is sort of, I don't know, it's not really asteroids because he moves in any direction. Asteroids would be left and right would rotate, and then forwards would be accelerate, and back would be decelerate. Maybe we can do that. Let's have a go. Right, so the next thing I want to try is making some sort of, I don't know, super sprinty style car that can drive around by pressing left and right and accelerate with forwards or the fire button or something like that. Again, we're just messing about, trying to learn this stuff. So what I've got so far is a little car that you can turn left and right. Doesn't do anything else yet. This code I took from my other video where I worked out how to do rotation and everything with the sprite library. So go watch that if you need to know how to do that. I've got this little animation structure that's got all the different combinations of mirroring, flipping, rotating and choosing the right frames. There are only 3. Here we go. So there's 3 frames, which if you flip and rotate them, does all the different 8 combinations. And then all I'm doing is if you press left or right, I'm adding 32 to an angle variable, because in my world there's 255 degrees for an angle, because it fits nicely into an 8-bit int. And that's the thing we're going to mess with next, using sine and cosine with fixed point maths. Some of this junk is going to go away, I just pasted it in. So let's just get things sorted. So if you press down on the stick, we're not going to do anything. If you press up on the stick, otherwise nothing. Left and right I've already got. We'll keep the drag in because that is the thing that we do now, and the limiting the velocity. We'll turn back on the position, and the rest is the same. I messed up my indenting as well. Let's fix that. Right, and then you should be there. I think that's right. Okay, anyway. So, what are we trying to do? We're trying to rotate the little ship. Well, it's a car, but it's a spaceship as far as anyone cares. It's this kind of asteroid style motion. Where is it? Spaceship motion. There, this kind of thing, where you can steer it and you can thrust around in circles. Except mine is also going to have braking, because that's a good thing. So this is fairly rudimentary physics. It's not even physics. By the way, ignore the wind if you can hear it. I'm not sure if it comes through on the camera. Yes, you can see wind, can't you? It's a bit windy outside. Right, so the acceleration is the cos of the rotation times the magic acceleration number. Okay. So if you press up, I wrote this down on a sheet as well. So acceleration.x equals, now I have a cos function that I made myself. There it is, we'll literally just call it cos and sin. And here's a big table of floating point numbers that I calculated using an Excel spreadsheet. I'll show you that in a future video. Ignore this bit, I need to play with that later. See, I could use this, it kind of tries to work out in between values. But since the car only has 8 positions, it would look weird if it could go like at, I don't know, 47 degrees and it was still pointing diagonally. It looked like it was sort of sliding sideways. So the cos of the angle times the magical acceleration number, which is acceleration amount. And the y is the same thing but sine. Oh, that was the nice thing about this. This is the table of cosine, and you just work out sine by doing it sort of quarter of a turn back, because that's how it works mathematically. Right, otherwise, I don't like the way this picks the wrong one. This IntelliSense is pretty stupid. Well, as soon as I type more, it goes like, oh yeah, maybe you want that one. I also don't like the way it pops up tooltips on top of everything whilst I'm typing. I'll often be trying to copy something from a line above and it pops a tooltip up that completely covers it, so I can't see it. Right, we've got acceleration, a bit of drag. There, right, let's run this. I have no idea if it's going to work. No, it doesn't even compile. Doesn't like cos and sin. Have I included them? Fix. Oh no, whoops. There. Okay, it compiles. Alright, let's see if it even runs. Yeah. What is even going on with that? Ooh, look, that's completely broken. Yep. No, no, that's not working at all. That's gone crazy. I like the way it sort of judders and then disappears. Okay, we need to work this out. What is even going on with this? Oh, why is this not working? What have I done wrong? Oh, that saves a lot of effort. Nope, still goes way off into the other corner. I suspect part of the problem is the direction it moves is not the direction that I think it should be moving in. But then I don't understand the weird juddering mess. Okay, let's just reset you so you're not whizzing away. Right, so, bit of hackery later on, and this is very much not maths at all. This is now just hacking things till they work, which actually feels more like a thing you'd do on an 8-bit processor, where sine and cosine cost a lot of power. I couldn't work out why it was going mad. I think it's just moving too fast. But then I realised that there's only 8 positions, and they're all the diagonals, so I can just work out a vector to go in that direction. So I did. And now, if you press up, it just works out which one of those it is and multiplies it by how fast to go. And off you go. So I can go forwards and stop. I can go diagonal. And diagonal. In that funny way that diagonal is faster. The only annoying thing that I don't quite like is that you can't steer and move. So, you know, I should, as I spin, actually go in that direction. So I should have curved in a circle then. And it all feels a little bit weird because you can't press forwards and steer. So maybe that actually should be in stick fire instead. Let's try that. Okay, it needs to go a lot slower. So if it's going faster than 8 was a random number. Let's put 3. I have no idea what these numbers are. See here, these numbers are just what feel and look right on the screen. So again, we're just budging things till it looks right, which definitely feels like 8-bit coding to me. We're not trying to recreate Unity. We're trying to make a little square on the screen that looks like a car moving a semi-pleasing way. Oh, you know, that's definitely more controllable. I need to work out the slightly better maths for diagonals. Now playing this, I realise that you definitely need more than 8 directions for a driving game. Otherwise it's all just a little bit too diagonal. But that's cool, because now I've tested this in an afternoon instead of investing like weeks in trying to write a driving game and realise that my controls suck. Right, that's quite pleasing actually. Very good. I need to come back to the sine and cosine stuff because that should have worked. I don't understand why it didn't. It's doing the same thing. But anyway, that's kind of the point of these videos. It's just me trying stuff, trying to figure things out so that I can produce something a bit more interesting. So yeah, that'll do for this video, I think. If you thought this was interesting, give it one of those thumbs up things. I'll try and do one of these every other week so that I can kind of build things up. I want to make a game. I don't know what game I want to make, so I want to mess around trying to figure out what I could make. But that's the problem with these coding type videos. They take a long time to produce, and I want to make things that over time I can see how much I've improved and what's gone on. So that's kind of the point of this stuff. Just kind of plodding away, 1 week at a time, trying to work something out. So yeah, if you thought it was worth watching, give it a thumbs up. If you didn't, well, you're probably still not watching, so I don't really care anymore. I hope you're having fun somewhere else on the internet. But yeah, if you stuck around, thank you, and I'll see you again. Tried not to sneeze on my screen. Sneezed right on you instead. Oh, good God. Right. Well, I've woken up now.